I thought I'd make a little video and just run through the problems from that mock test number 2. So this one, part A says, right, use a midpoint Riemann sum with 3 equal subdivisions of equal length indicated by the data in the table to approximate the value of f of 6. So for the Riemann sum part, right, we're estimating the integral from 0 to 6 of f prime of x. Okay, if you look at it, it wants 3 equal subintervals. It goes from 0 to 6. So 6 1 to 0 is 6 divided by 3 would be 2. So we're doing intervals of 2. So there's my first one. There's my second one. There's my third one. Look at the midpoints. Those are our heights right there. And the width is 2. So I'm just going to go 2 times 3.5 plus 2 times 0.8 plus 2 times 5.8. This the only part you have to be careful with is it does tell us a function at 0 is already equal to 20. So that's an initial condition. So I really need to take this answer and add 20 to it. So it's 20 plus that. So over here I need to, this comes out, I need a plus 20 down there. If you multiply all of that and add it all together, I think it was 40.2. You guys can double check that on the key, but so probably the biggest mistake there I think is forgetting the plus 20. I was looking at the answer key as far as the points. You get a point for the midpoint sum. You get a point for adding the 20. They called that the first, showing the first fundamental theorem of calculus, but you just need to show that you added 20. And then you got a point for the actual answer, which was 40.2, which I just checked right there. So there's 3 points on that test, on that part. I thought this part B was the trickiest part. It says determine whether the actual value of f of 6 could be 60. If you go back to here, right here it tells you, right, that your y values for your derivative are always between 0 and 7. So we already know, right, you can look at these y values, right, it goes 4, 3.5, 2.8, right, they're always under 7, but in between maybe they could go really high. But this tells us that they don't. The highest they ever get is 7. So remember, you're trying to find the area under the curve. So the max it could possibly be is if it was 7 all the way across. So if you think about it like this, if your derivative was 7 all the way across, that's the max you could actually get. That shape, the area would be 6 times, right, and the height would be 7. So the max that function could ever equal is 42, plus the 20, right? Plus the 20 because the 20 is the initial value. So the max it could get to is 62. So the question's asking, could it equal 70? Your answer would be no. And I would say, it tells us that f prime of x stays between 0 and 7. So the biggest it could be, at the highest it could be all the way across to 7. So the greatest the area under the curve could be is 42, plus the 20 is 62. So 62 would be its max value. That one was tricky. There wasn't a lot of work to do, but kind of tricky to think through. Okay, so this one wants us to evaluate, oh, by the way, that last problems were 2 points. One for the answer and one for the explanation. Okay, on C here, we're trying to find the integral of f double prime of x from dx. Just remember the fundamental theorem of calculus. If you remember that, this one's pretty easy, right? If I take the derivative, or the integral, excuse me, of, so if this is f double prime, the integral would be f prime, of my upper bound, minus the integral f prime of the lower bound. This will give me the answer to this. And we know what f prime of 4 is and f prime of 2 is, right? We can just look back at that table. F prime of 4 is 1.7. F prime of 2 is 2. So we're going to go back to here. This would be 1.7 minus 2. So the answer is a negative 0.3. So fundamental theorem of calculus, right? If I integrate it, find the integral, I take the upper bound minus the lower bound. That one was worth 2 points. One was for just showing this, and then one was for the answer. Okay, the last question really has nothing to do with the rest other than we're going to use a table. It tells us in the original problem, get that back here, it tells us that f of 0 equals 20. That was given to us. So if I want to find the limit, I'm going to try direct substitution first. I'm going to plug 0 in. So if I plug 0 in, I'd get f of 0 minus 20 e to the 0 all over 0.5 f of 0 times f of 0 minus 10. So we know f of 0 is 20, so it'd be 20 minus e to the 0 is 1, 20. 0.5 times an f of 0 is 20, so that'd be 10. So anyway, we end up getting 0 over 0. So direct substitution doesn't work, but because, remember, if you get infinity over infinity or 0 over 0, that means we can use L'Hopital's rule. So let's take the derivative of the top and the bottom. Remember, you just do it separately. So I would make a note somewhere. Know that you're applying L'Hopital's rule. Okay, so I have the limit, make sure I add the limit again, as x approaches 0 of, take the derivative of the top, that'd be f prime of x minus, the derivative of e to the x is just e to the x, and 20 is a scalar factor, so just nothing changes, just 20 e to the x, over the derivative 0.5, again, is a scalar factor, times the derivative of f of x, which is f prime of x, and the minus 10 is a constant, it's going to go away. So now we end up with this. Now we're going to try plugging 0 again. So I'm going to go f prime of 0 minus 20 e to the 0 all over 0.5 f prime of 0. So look back up at your chart again. It tells us what f prime of 0 is. F prime of 0 is equal to 4. So I get 4 minus 20 over 0.5 times 4. So that would be, what, 2? I mean, you can simplify it from there. If you look at the answer key, you get 1 for, for recognizing L'Hopital's rule, and you get 1 point for finding the actual answer. So make sure you make a note of this, because even if you make a mistake in there, if you show you can use L'Hopital's rule, you're going to get a point off of that. So there's those 4 questions. Hopefully that kind of makes sense. Make sure you go through it really carefully like we've talked about. It's really valuable to have these questions as part of your notes, so when you go to take a test, you could get questions really similar to this, and if you do, you want to be able to have this as a resource. Okay, let's go through number 6 from the 2018 test. So it says, consider the curve given by the equation 2 times x minus 3 equals 3 plus cosine of y. And it tells us for all points, and it tells us our derivative is always between 2/3 and 2. It wants us to show that the derivative of this is equal to this. So really it's giving us the answer, we just have to show it. So I need to take the derivative of the top. So I'm going to times through by that 2. So I'm going to go, that'd be 2x minus 2y equals 3 plus cosine of y. I just distributed the 2 through. Now I'm going to take the derivative. This would be 2 minus 2, and remember, we take the derivative of y, it's y primed, equals, the 3 is a constant, it goes away. The derivative of cosine of y is negative sine of y. Do not forget to times that by the derivative of the inside, times it by our y primed. Okay, now I need to solve for y primed. So to solve for y primed, get everything with the y primed on one side and everything without it on the other side. So I'm going to move this over. So I get 2 equals now a positive 2y primed minus sine of y times y primed. Factor out of y primed. Y primed times 2 minus sine of y equals 2. Divide by 2 minus sine of y. 2 minus sine of y. Okay, now I've just shown up here, right? We got this up here, so part A is done. We've gone through all the steps and shown that. Let's look at the scoring guide here. That gets you 2 points right there. Okay, you do the implicit differentiation correctly for 1 point, and then you show, you do all the algebra to show that it actually equals that for the second point. Okay, number 2. If y is between negative pi over 2 and pi over 2, there's some point on P on the curve through which the tangent to the curve has a slope of 1. Find the coordinates at that point. So what we're trying to find out is when does the slope equal 1? So we have our derivative, right? Our derivative is this, dy dx equals 2 over 2 minus the sine of y. I want you to notice we don't even have to know part A to do part B. Like, the derivative was given to us. So just keep that in mind. Anyway, I want to set that, I want to find out when is the slope equal to 1. So when does that equal 1? So I need to solve that equation. So 2 over 2 minus sine of y equals 1. So I'm going to times this part up to the top up here. So I end up with 2 equals 1 times 2 minus the sine of y. So we end up with that. Solve that. Minus 2 over 0 equals negative sine of y. You know, you can divide by negative 1. You end up getting a sine of y equals 0. Hey, you had to have the unit circle memorized, but now you don't. I would have the unit circle in front of you. You know, print off a copy if you don't have one. They're on the line. There's a million of them. The sine of what angle equals 0? Well, that if you know my unit circle, the sine is equal to 0. You have to be between negative pi over 2 and positive pi over 2, so it's right there at 0. So that gives me the y coordinate. Now be careful, it wants the point, so I need to find the x coordinate. So I've got to go back up to the original equation up at the top and plug 0 in order to find what the y coordinate is. So the original equation, let me get that back up here, is this: 2 times x minus y equals 3 plus cosine of y. So I'm going to plug 0 in for y and solve. So I get 2 x minus 0 goes away equals 3 plus the cosine of 0. That's right here again. That's 1. So 2x equals 4. Divide by 2. Divide by 2. So the cosine, so x is equal to 2. Hey, this is good. I just realized I made a mistake in my answer key. I was just looking at it. I said on my answer key, I said the cosine of y was equal to 0 right there. It's not. It's equal to 1. So this should come out to be 2. I think in my answer key I had 3/2 because I made that mistake right there. So make sure you take into account. I will fix that, but for now it's going to say that if you check it. So just a heads up on that. Okay, those problems were worth, those were 2 points. You got 1 point for just setting the derivative equal to 1. So just that one step of taking your derivative and setting it equal to 1 got you a point. And then you got a second point for working it all out and finding the coordinates of that point right there. Okay, C, determine the concavity of the curve between negative pi over 2 and pi over 2. Hey, concavity we know is a second derivative. So we've got the first derivative, right? dy dx, or y prime, is equal to 2 over 2 sine of 2 minus the sine of y. I've got to find the second derivative, though, to check concavity. So I'm going to do that. So y double prime equals, we got to do the quotient rule. So it's the bottom, 2 minus the sine of y, times the derivative of the top, minus the top, times the derivative of the bottom. The 2 is going to go away. The derivative of minus sine of y is a minus cosine of y, y prime. And that's all over the bottom squared. Let's do some simplifying. If I times this by 0, that part's just going to go away. So now I've got y double prime equals, on top, the negative and the negative will make it a positive. So it's 2 cosine of y. I'm going to leave that y prime off to the side there, times y prime, all over, I forgot to square that in the bottom, sorry, all over 2 minus the sine of y squared. Okay, I need to plug this in. Y primed, we know what y primed is. It's right up there, right? So I'm going to replace this with this. So I end up with y double prime equals 2 cosine of y over 2 minus sine of y squared times by 2 over 2 minus sine of y. So I get all the way done. I end up with my second derivative equals 4 cosine of y over 2 minus sine of y cubed. Okay, now I've got to think about what happens between negative pi over 2 and positive pi over 2. So if you think of the unit circle, that's this half over here, right? Negative pi over 2 to positive pi over 2. No matter where I am over here, the cosine is always positive. So the top is always going to be positive. The bottom, I've got 2 minus the sine of y. Remember, sine of y is always less than 1. So if I go 2 minus the sine of y, it's going to be 2 minus a number that's less than or equal to 1. It's always going to be a positive also. So the second derivative is always positive. So you want to make a note of that. Second derivative, I'm going to say it, not write it down, but you would say the second derivative is always positive from negative pi over 2 to positive pi over 2. Therefore, the function is always concave up. Okay, last question. Oh, that one was worth 3 points. You got 3 points for finding that second derivative. Sorry, 2 points, for getting this, this or this. That was 2 points right there. And then you had to give a reason for the 1 point. So you're saying it's always concave up because the second derivative is always positive. As long as you have that noted down there, then you're good. Hey, D was out of all both questions. D required me to think the most. It says let f of x be a function defined by implicit differentiation by, there's our function, that is continuous on a closed interval from 2 to 2.1 and differentiable on an open interval from 2 to 2.1. You use the mean value theorem on the interval to show that. F of 2.1 minus f of 2 is greater than or equal to 1/15 and less than or equal to 1/5. A lot of mumbo jumbo, right? Hey, we get to use notes now. So remember the mean value theorem, what it says is if I take the function and I find the average rate of change, f of 2.1 minus f of 2 divided by 2.1 minus 2. As long as the function is continuous and differentiable, that means there's some point C between 2 and 2.1 where the instant rate of change, right, f prime of C, the instant rate of change is equal to the average rate of change. So now, if you notice, I'm trying to get this part right here. I'm really close to that right there. You got to remember in the original problem, this is the part that it took me a little bit to figure out. If you look back at the original problem, at the very beginning, it told you something about the derivative. It said, it said the derivative, dy dx, is always between 2/3 and 2. If I come back to here, that means this has to be between 2/3 and 2. Right, and then that means that, the f prime of C is equal to that average rate of change. That means I can replace that and say f of 2.1 minus f of 2 divided by 2.1 minus 2 is 0.1 is also between 2/3 and 2. We'll solve this, to solve this is a compound inequality. I'm dividing by 0.1, so I need to times everything by 0.1. 0.1 is 1/10, so I'm going to times everything by 1/10 to get rid of that. It's supposed to be a 2 over there. And when you do that, you end up with 1/15 less than or equal to f of 2.1 minus f of 2 less than or equal to 2, it's supposed to be a 2 there, 2 times 1/10, which is 1/5, and that's what we're trying to prove up there, right? That's a tricky problem. That's how you get a 5 on the test. Actually, you don't even have to get that to get a 5 on the test, but that's how you get a perfect score there. Hey, these are challenging problems. If you get them all right, then you're insanely smart, and you deserve higher than a 5. Just remember, you're looking at a 38% to get a 3 on the test. That means, you're getting less than half right. You need a, what was it? I haven't written down here, but it's a 50-something% to get a 4 on the test. And usually it's right around 60% to get a 5. So don't think as you go through this, don't get discouraged if you don't know how to do part of it. Do the best you can. I would try every part all the way through. If you noticed, like on that last problem, one of the problems had nothing to do with the rest, like that L'Hopital's rule problem. You didn't have to know how to do any of the rest of it in order to do that. So you need to try every problem. Don't stop at one part because you get stuck. Anyway, I will post this online so you can watch it if you want to, and then I'll have that mock 3 test ready for you tomorrow. Thanks, guys.